All right, so height of the commons lab. If you want to find the purpose, find the height of the commons way in an unusual way, knowing only a lateral distance. That's pretty good, except my rule is you can't just take the purpose that we give you and say it word for word. So you need to put the purpose down, but you can't just type it exactly what they said. You have to say it in your own words. Okay? It's not that hard, but it keeps you from just being a cut and paste. So you have to think about it, and you have to restate it in your own words. All right, so don't lose points for having copied it exactly or just took a picture of it. All right, next, you're going to have a thing called a sketch. Well, I did give you a format for the sketch, like in this case, but I also drew one on the wall that I kind of thought was better than this one. But if you want to use this one, I totally understand. That's fine. This is a pretty good sketch. You just have to fill in everything in there. Okay. All right, so the height of the commons lab also needs the procedure. Procedure is like what you did. First, I took an angle measure. Then, I went 90 degrees from that and took another angle measure. Then, I counted how many steps I did. Then, so like that's kind of where you describe what you did. Calculations is where you actually like solve your equations. In this case, here's the hints that I wanted to give you on that. If you have this height that you got, let's say 45, and then you knew this was 25, and then this is the height of the commons, do you get that you don't need to do anything big and complicated to find the height of the commons with that? That's like super easy. If you thought that was the lab, what? Like, that's not a lab. That's like a 2-second problem. You just do tangent of 45 equals h over 25, all right? And then you get the height of the commons, except one thing. You didn't factor in what? Your own height. So your own height, you were seeing this like this. And now your height, we said to add in 5 feet for that. So don't forget that. Okay, but still, that'd be too easy for the lab. So if you just have that way, you've missed the point. The point was that you had to take then a 90-degree angle to that and walk like 10 feet over this way and then do it again. And then this, let's say this has gone down to 40 degrees. Okay. Then you'd have a new triangle to work on, and I don't know the sides of it. Let's say that I call this side Q, and this side, you can't call this side 25 though. Some people thought, well, if you leave the 25 in there, you're going to be able to just get the answer instantly again. The point is, how do you find it when you only know 10 feet, 40, and 45, or something like that, whatever your data was. And so then you got to set some things like this is going to be called Q. This is going to be called R. And then this is going to be called H. And then you got 3 variables. If you have 3 variables, you will need what? 3 equations. So let's get one equation that's super simple. Using H and R, please write an equation right now that uses H and R. Just do it off on the side. You can always erase it in a second. Did you get tangent of 45 equals TOA is opposite over adjacent H over R? Raise your hand if you had that. Okay. What? H equals R? What are you talking about? No, H is not equal to R. Now, if you knew, okay, if it was 45, 45, 90, okay, that's true. It's interesting, twist, because that's the only case in which that could happen. All right. Okay, anyway, back to, you got a point there. I shouldn't have used 45. Let's see, 44 and 38 or something like that. All right, so then the normal equation for this is tangent of 44 involves opposite and adjacent, which is H over R. And so there you go. There's an equation. That's one of your 3 equations. All right. Yes? You can't just use the 25, because otherwise, what's the point? You already know the height of the commons. You can just say, boom, I know the height of the commons is 25. But no, stop. If you knew this side was 25, then there's no point to the lab. It's just like 5 seconds and I'm done. Then you missed the whole point. If you use that side being 25, then you aren't using the 10. Why would you ever use the 10? You wouldn't need that or this. You get what I'm saying? Okay. All right. So the point was, if I am finding like the height of the walleye on the back wall there, but I can't get to it. If I could walk there, it would be super easy to just walk that distance and I can find it super easy. But the point is, can I take an angle, go 90 degrees from it, go over here and take another angle, and then find the height of the walleye? All right. So there's a few tips for you. Yes, you do need to have a purpose and a procedures, and if you haven't noticed yet, at the end of that there's this thing called reflections. Let me see if I could find it in here. That's a different file. Hold on a second. There we go. At the conclusion. The conclusion is also the conclusion and reflections part. That's where you reflect and you give at least 3 math-related reflections. Here's the description of conclusions and reflections. If you're not listening to this right now, you're about to lose 3 points. Don't be all bitter tomorrow that if you don't have the reflections in the conclusion and reflections, then you will lose points. Get them there. This is in that file. You should be able to find that file. You all have a past to Schoology where you can find this in the folder called Labs. All right. So I think some of you thought, oh, it's super easy, lab, that's nothing. Well, you weren't maybe paying attention to what the job was. All right. So I wanted you to be able to know how high the commons was by just using this super simple way. But that's not how you prove you know the hard way, which is knowing that distance being, let's say, 12 feet and taking another angle measurement. All right. Okay, so enough about the lab. Now let's talk about what you're supposed to know so far. This is about radians. I want to see quick if you remember. Would you please put up where 3 pi over 2 is? 3 pi over 2. If you get stuck, put a pi first. That's pretty easy. You get the pi's here. And then you could put up pi over 2, which is halfway to pi, which would have been here. And then how many of you knew it was down there? Raise your hand if you had that one right. Awesome. Now what's another name for 3 pi over 2? Negative pi over 2. I heard that, and that was right. Because it went this way, pi over 2. Okay? What's another way to say 3 pi over 2? Hint, use degrees. 270 degrees, very good. And one more, how about negative? Negative 90. And then one more, how about a really big angle that's even bigger than 270? Because 270 works, but what if you went all the way around again? All right, it'd be 360 plus the 270. 630. Yes, yes. I get it. You got close really fast. But okay. So then the last one is, let's see if you remember your classic 30, 60, 90, except I want to draw it in the context of a circle. So we're putting a 30, 60, 90, but we're putting it right there. If this is 30, 60, 90, then would you agree this is 1, and then put in the rest of the sides, please? Draw that. I'm going to pause for a second. Let's set something up. Okay. So I'm back. And you should have said this is 1, 2 in the square root of 3. But I hope you remember that sometimes we want the radius of our circle to be 1. Think for a second. If the radius is currently 2, don't say subtract 1 from each side, because that wouldn't work. What could you do to make it stay the right proportions and yet have a radius of 1 instead of 2? Divide everything by 2 is correct. And that way this has become 1, and this is 1/2, and this is root 3 over 2. And one of the reasons we don't have you memorize it this way is because these numbers are way harder to remember than 1, 2 in the square root of 3. So what I'd do is just do it that way. Start with 1, 2 in the square root of 3, but then just be smart enough to know, how do I make this have a radius of 1? Divide by 2. Everywhere. You might be like, I'm not doing it that way. Oh, okay, well, then you're not going to understand when we get to the tough ones. You have to be able to handle this, because a lot of times the radius is 1. All right, there's one more that's like that. Let's get this one down. Make a different circle, and would you please make me the 45, 45, 90 right here? And label its sides. The angle in the middle is called the central angle. It's like the middle child. No, it's not the middle child. It's like the firstborn in the family. Gets all the attention. Although usually the way the family dynamics work, there's been whole books written on this. First child versus middle child versus like third child. And if you have only 2 kids, then you don't have the middle kid scenario. You just have a first kid and a last kid. And then, anyway, how many of you are the oldest in the family? All right. All right. So then, if you're the oldest in the family, here's the theoretical. Please be quiet. You're just distracted. The theoretical thing where, if you are the oldest, you're supposed to be the one who is the biggest achiever. Tend to be the person who is like well, you go through everything first in the family. Like, you're the first person to get the driver's license because you're the oldest, and you end up being, there's maybe a lot of pressure on you because you're supposed to set a good example for your brothers and sisters and all that stuff. So there's some interesting family dynamics that happen because of that. Who is the middle children? All right, not too many in here. Only 3. Okay. And the middle child, is it true? The middle child gets ignored compared to the oldest and the youngest. My daughter was middle child. She was totally a believer. She was like, yeah, older brother gets, like, well, he's the one who goes to the Air Force Academy, and, everybody like, ooh, big deal. And then she goes to a normal school, and then, didn't even remember that you went there or whatever. And then the baby of the family usually is one who likes to get, like, kind of be the jokester of the family and, like, tell jokes, and you have people kind of, I don't know, they try to get attention. Anyway, that's not to say that all the youngest, who's the youngest out there? All right, I'm one of the youngest. Sometimes the youngest in the family, well, there's a lot of things you can be. You can be a little bit of each. Even if you're the youngest, you can be an achiever. You're going to want to get attention, and you can also sometimes feel neglected. All of those things can happen to you even if you're at any spot. All right, anyway. This spot right here, of the 3 angles, though, that's the only one we care about. Don't get confused about the other ones. That's called the central angle, and it's a big deal in what we're doing today. And if this is truly a 45, 45, 90, then this is a 1, 1 square root of 2. But wait, what's the problem with that? What's the radius? It's supposed to be 1. So how do we fix this? So the radius is 1. Divide by root 2. Very good. That way, that, which is the radius, is now 1. But then, I know I mentioned this at the beginning of the year. Let's see if you remember it. 1 over root 2 can be what's called rationalized by multiplying by root 2 over root 2, which makes it root 2 over 2. Does that ring a bell? Remember me saying that in this one? Root 2, 1 times root 2 is root 2 over root 2 times root 2 is root 4, which is 2, root 2 over 2. Okay. Now, then there's something that pulls together everything that you know into one place. So this is kind of a big deal. I'm going to pause for a second. It's been coming for a while. Everything we've been doing has been leading up to this moment. If you could put everything that I've just taught you into one diagram and memorize it all, this unit circle could answer pretty much every question about trig that's on the ACT. Pretty much every question that I ask you about trig for the next, 2 months, it's all up there. Every bit of it. And you might think that this thing, there's no way I could memorize this. You actually have it. You have all of it in your head. You already know where the 30-degree angle is. You know where 45 and 60 and 90 are. Those are easy. And you just keep counting. And that's easy. You just have learned the radians part. We just finished all of that. And if you notice, all of these are exactly the same. That means the only difference is where the negatives are. I want you to think for a second. If you go to the left, do you get things would be negative if you go to the left to get to them? Do you get why all of these are negative? Because you have to go to the left to get to them? Okay, and then how about these? They're all negative. In this quadrant, isn't any point in that quadrant going to have negative? Because you have to go this way, and then you have to go this way to get to them. They're all going to be negatives. Then, a few other little observations, and you'll realize you actually know all of this already. That's a 30, 60, 90 triangle. Do you get that this is also a 30, 60, 90, and it's just the 30s and 60s that are in reverse, so therefore those are just reversed? It's just a 30, 60, 90 from a different angle. All right, and last, I just showed you this one a second ago. It should be fresh in your mind. The 1, 1 square root of 2 triangle. But wait, Mr. Server, that's not what they are. Because they've all been divided by square root of 2. Just like Hunter said, and he was right. Final answer. 2 over 2. We talked about that already. Okay, you know all of these numbers. Now let me show you how you can use them. And this music's kind of freaking me out now. So there. What you're going to, I was going to do that bigger and louder, but the guy came over next door and he said, "We're testing this out, we're so sorry." So anyway, I kind of toned it down a little bit for the next door neighbors. If I asked you what the sine of 30 degrees was, I asked you to memorize it a million times, but some of you didn't. What's the sine of 30 again? 1/2 or 0.5. Good. Let me show you where it is. It's right there. Why is the sine of 30 there? Because, would you agree, this is where the 30, 60, 90 triangle is, right? Oh, wait, there's another 30, 60, 90, Mr. Server, right here. Yeah, and there's another 1/2 right there. But we'll get to that in a second. So, I now need to pull together one other thing I told you, but this was a long time ago. Do you remember me showing you this, where this was x, and this was y, And this was the radius. Oh, different color. Green. And the radius is supposed to be 1. I missed them. I'll try again. Does that ring a bell? Do you remember that? And the angle that was important was the central angle. And then I said, what's the sine of that angle? And you said opposite over hypotenuse, so what? Y. But most people forgot it because we really didn't use it much. But I introduced it a long time ago. It's coming back, and it'll be super important today. Sines Y, what's cosine? X, because cosine's adjacent over hypotenuse, and so it's X. And tangent is close. Y over X, because it's TOA of this angle, opposite over adjacent, so Y over X. Sine is Y. Repeat after me. Sine is, cosine is, and tangent is. All right, good. And I don't want you to say, when I said it in a different hour, they were like, sine is opposite over hypotenuse. Nope, that was in the old days. Because that was when you could only do trig with right triangles. Now, we have to be able to do things like, what's the sine of 330? Try drawing me a triangle that has a 330-degree angle in it. You can't, because triangle angles add up to 180. You can't make one with a 330. You can make one that kind of goes in that neighborhood. See, here's the 330, but it's not going to have a 330-degree angle in it, is it? Okay, so you can't do your triangles, your trig with just triangles anymore. That's why we moved to the circle. All right, so what's the sine of 330? What did I ask you 1 second ago? What was the sine? Come on, you've already forgotten? That's so sad. What's the sine? Y. Well, then, of this point right here, which of the two do you think is the Y? The negative 1/2, because it's in the Y spot. So sine of 330 is negative 1/2. All right, how about this? What's the cosine of 210? Well, here's 210. Negative 3/2. If you're like, that doesn't make any sense to me. Let me back up and show you something. Would you agree that that would be a right triangle if I draw it that way? That's a right angle, true or false? This is a 30-degree angle, true or false? That's a 60-degree angle. Are you with me so far? And then opposite over hypotenuse, right, is sine. So from this angle, I said it was all about this angle. It's like the first child. Everybody pays attention, blah, blah, blah. So sine is the opposite over hypotenuse. 1, 2, and the square root of 3. Does that ring a bell? Okay. So if I wanted to do cosine, oh, wait a minute. I'm about to bring up the most common mistake on circle trig is you get into your sides and you forget that one of them is negative. Or maybe even 2 of them. What's also negative here? The 1. Why? Because to get from here, which is where you always start, to over here, you had to go that direction. Do you get that's a negative direction? All right. And how about this? Do you get that that's a negative direction, and therefore that's negative 1? All right. So I feel like I know this is last hour of the day, and you're tired, but this is super important. I need you with me for a few more minutes here. So if I was going to ask you to find the sine of 210, it would be the Y, because opposite over hypotenuse. See? Negative 1/2. See? And if I wanted to ask you what the cosine of 210 is, it's the X, because cosine is X, and cosine's adjacent over hypotenuse, and therefore it's that. All right, so now can you buy this at least? Having the ability, if you had this thing memorized, some kids do this. They memorize the whole thing, and then they go and they draw it on their test. You'd think, like, wouldn't that take forever? Nope, it really doesn't. You don't have to draw all the angles on it because you know them after a while. You know that this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And these are repeated 4 times. There, 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 there. They just have negatives thrown in. These are repeated 4 times. I'm going to use my highlighter. Wait, there it is. That, and that, and that, and that. I will say, if you had photographic memory and you could just like look at that page and then like recall it later, wouldn't that be an amazing skill? It'd be right up there with speed reading. Photographic memory is a real thing. There are people that can do that. Literally, they can look at a page, then turn away from it, and then somebody's like, "What? Tell me what's on the bottom of the page." They can tell you everything that's there. That'd be a huge advantage. So is speed reading. I have a friend that actually does it. He's the kind who can like read a page, turn the pages that fast, page, and he's memorizing it as he's going. Some people think it's like a trick. It's not. It's a real thing. I know another teacher who can speed read, and she's a good teacher. You want to learn something? You just grab a book, flip through it, and you know the whole thing in like an hour, maybe even less. Can you imagine what advantage that would be in college? My friend that knows how to do this, he would read every book in the first week. So he's done with every book from college in the first week. And everybody else is like, "Oh, did you reading thing?" And a lot of people don't even do it because it's, you know, long and difficult. For him, it's just like sit there for 45 minutes to get the book read. I proposed a while back that Minnetonka should spend. He told me what it took to learn how to speed read. There's computer programs that can help you do it, but you have to do it every day, and that's what people don't like because it's a little painful at first. You got to force yourself to read it faster than you ever have read before, and it's not fun, and it takes a while. But wouldn't you agree if you had spent all of 7th grade or 8th grade just learning to speed read? That's all you did for that 1 hour every day. But you right now could speed read. Would that have been a good trade? Absolutely. To be able to speed read, oh my gosh. Some teacher assigns you like, 8 chapters of your book, you'd be like, 15 minutes later, okay, done. Your friends would be like, "I hate you." And then college, this friend of mine that would read every book in the first week, then he would ask the professors, "Hey, what's your favorite books on this subject?" Because they're like an expert in the subject, right? And he's like, "Oh, I think this author's great and this author's." So he'd just go read those books next. So in the second week of college, he'd read the professor's favorite books, and then he'd quote them on the essays. Can you imagine how, like, teacher would be like, "Oh my gosh, this guy's a genius. He knows all the books that I know." And anyway, I suggest that we give this Minnetonka kids that superpower. And I think the thing that people don't like understand about it is it's one of those things that's not fair in life. Some people can pick it up pretty easily, and some of you right now, if we did that, you'd all be speed readers and it'd be fine. And others of you, we could have tried to teach you all of 7th grade to speed read and it wouldn't have worked. But I still think it would be worth it because some of you would have picked it up. Some of you would have tripled your speed. Some of you would be 10 times faster, and some people wouldn't be any faster. But I still think it would have been worth it. That's my opinion. All right. So if you knew this whole chart, do you get the patterns I just highlighted there? Like the yellows? They're all the same. They're exactly the same, except for negatives. Do you get how that's not that hard? Yeah. If you knew this, and then that is reversed of this, which, come on, you can't handle reversing, then really you just need to know these. And where do those come from? The 3069 and the 454590. So you actually know all of this already. You do. You can recreate any part of it. The hardest ones are the first two. I'd like you right now to recreate, without looking at that chart, what those two spots are. Hint, that's a 30. And you can't use 1, 2, root 3. Because the radius isn't 2. Take a second, recreate this spot. Because remember, we need those two because one of them's cosine and one of them's sine. Yes? it was voted down. They didn't give me a reason why. My theory is that a lot of English teachers, I think, don't believe that speed reading is real. I think that they think it's like a fake trick. And it's, but I think another reason might be that they would say, we can't do it because some kids would get that and get that huge advantage and other kids wouldn't. Do you get what I'm saying? And I get how that's not fair, but is that like, wouldn't it be such an awesome thing for the kids that would pick it up that it might be worth it? And yeah, it might separate kids. Some kids all of a sudden are genius readers and others aren't. It's harder to teach them. I don't know. There might be a lot of reasons why. But I've talked to a few English teachers and I don't ever get an answer that I understand. Like, why don't we teach speed reading? And I think they're like, because it doesn't work. I don't know. I know people that it does work. I know people that do it. So I don't know. I'm curious. And I'm not saying I can teach you to speed read because I can't do it. I just have two friends that can. One's a Minnetonka teacher. She's an elementary teacher, and she's like really smart and really good at her job. She won Minnetonka's Teacher of the Year a few years back. And I know another person who's a pastor, and again, he'll read like 3 books in a night, just like whole books, the whole thing, and recall it better than anybody else. Just, and he learned it in 8th grade because they said they made us speed read every day in 8th grade, and we learned it. And he was like, "That's all." And then ever since then, I just speed read. Didn't have to really do it other than just actually reading books. Didn't have to practice it. I encourage you to, I don't know, if I were you, can you imagine if you like dedicated a summer? If the Minnetonka doesn't do it, what if you just dedicated a summer to it? And then you were a speed reader after that. Can you imagine how much easier college would be? Oh my gosh. And I know I said the word sped read, and you're going to be saying that like for a week. All right. Sine is opposite over hypotenuse. That's a 1. So opposite over hypotenuse is that spot. You'd go over this much. Get what I mean by over that much? To the right. And then up that much, which is the y, which is 1/2. And the sine is the y, and the cosine is the x. Now that we got that spot, do you get it would also go over here? Those exact same numbers would be here. And then it would also go down here. And those exact same numbers would be right there. And it would also go there. And those exact same numbers would be right here. The only thing is that there's negatives. When you go this direction, you're going negative. When you're going this direction and down, both of them are negative. And when you're going this direction and then down, the second number is negative. There we go. See, I got part of it all filled out. All right, so what do you really have to be able to do? Am I going to make you memorize it? Nope. I'm just going to tell you you would be very powerful if you did. But if you want to do the second best thing to that, it's be able to draw triangles when you need to. So like, pull up this slide. It's in your presentation. 12-minute warning, so we'll get to the homework real soon. All right. And be able to, if I say, okay, pi over 4 is your number, be able to recreate that with triangles. If you know that's a pi over 4, do you get that that's a 1 root 2? And do you know what to divide everything by to make it be in the unit circle? What do? Divide by what? Root 2. And you don't even have to rationalize it, because I would have been fine if you'd have said, instead of root 2 over 2, 1 over root 2. They're the same. They're identical. It's just one of them has been rationalized because they did this. Root 2 over root 2. You don't have to do that part. If you want to just leave it like that, then you could recreate every little spot on the unit circle just one thing at a time. So let me see if you can do this. Would you please find the sine of 5 pi over 4? First of all, I better figure out where 5 pi over 4 is. Second of all, you might want to draw a triangle there. And unless you've already memorized it, because you spent, some of you are really good at memorizing. I feel like there's a thing where if you're younger, and it's probably just based on the person too, but you can memorize, some people anyway, can memorize things really quick. One pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. How many of you knew we were down here? Okay, then you should be making a triangle out of that. And then what angle did I say was the one that we all cared about the most? Central angle, that's this guy. And then, is this a 30, 60, 90 or a 45, 45, 90? And therefore, what are the sides? 1, 1, square root of 2. But we can't leave it that way because it's a unit circle. So, and now, what's the sine? Well, sine is the y of it. So how far this way do we go? How far that way do we go? Oh, this is the spot. Negative 1 over root 2, comma, negative 1 over root 2. And the y is, don't forget the negatives. That is the most common mistake in circle trig. I didn't label them with negatives on the graph. I did it here, but okay, so sine is which one? It's the y. There it is. Negative 1 over root 2. I'm going to back up in time. When I had it like this, did you understand it? Now do you get that these are actually in the negative direction, so they should be negative? And then the last thing is I divide everything by what? Because that way, this just turned into 1, and we wanted the radius to be 1. So I divide everything by root 2. And then what point is this right here? Well, it's how far this way did we go? Negative 1 over root 2. How far that way did we go? Negative 1 over root 2. And there it is. That's the spot on the unit circle. And then it can tell me sine or cosine. Well, they're the same thing. Yeah, that happens. Sine of 5 pi over 4 is the same as cosine of 5 pi over 4, which is not the same as the tangent. The tangent is this over this, which when you divide anything by itself, it's just 1. So the tangent of 5 pi over 4 is just 1. All right, then the last kind is, what if it isn't even a triangle? Like I'm over here, and all I see on the unit circle is it says 1, comma 0. Well, you're at 0 degrees, first of all. You can't draw a triangle with a 0 degree angle in it, can you? So you can't draw a triangle for that. So sine is, one more time, sine is what? Y. You got to keep that in your head. Sine is y. So what's the sine of 0 degrees? That's the y value. What is it? 0. What's the cosine of 0 degrees? 1. And what's the tangent of 0 degrees? 0 over 1, which is 0. How about this spot, 90? Would you agree that that's 0, comma 1? So sine of that spot is the y, so it's 1. Cosine of that spot is 0. Tangent's a weird one. It's the tangent of 90 degrees, also known as pi over 2. 1 over 0. What the heck is 1 over 0? Undefined. There's no answer for that one. All right, so now I've got to get you to see which ones we're doing for homework for tonight. And it's only the first page. I made your life easy. Just that. Now, let me do a couple with you even so you can see they're not that bad. You could go look these up. We've got a chart for that. You know what I mean? I can find them all on the chart. And I'm okay with that as long as you understand I'm not going to give you the chart. You have to make it yourself if you want it on the test. Okay? So they want the sine and the cosine. Some people think that SIN and COS are words. They're not. They're shortcuts. Sine is short for S-I-N-E, and cosine is short for cosine, C-O-S-I-N-E. Okay, and then I want sine of this angle, so sine of 0, and I want cosine of 0. You've never done anything like that before because you always had right triangles. They didn't have 0-degree angles in them, so you have to do it this new way. In my opinion, the best way to do it, draw yourself a picture, and you don't do the whole chart because that's like takes forever to make, but you make this part of it. Is that 0, 1, or 1, 0? 1, 0, very good. And now what's the sine? It's the y value. So what's the sine? 0, and what's the cosine? There you go. How about for the next one? Sine of pi over 4 and cosine of pi over 4. Well, what's pi over 4? Pi over 4 is 1/4 of the way to pi, which is over here. So that's this. And so, ooh, cool, I got a right triangle. You can always go back to the right triangles. It's a 45, 45, 90. So it's a 1, 1, root 2. But wait, I got to divide everything by root 2. And now, what's the sine of this? I can look at this and say, what's the sine? It's the y. 1 over root 2. What's the cosine of it? 1 over root 2. If that's bothering you, you can always divide them by 1, because you know sine is opposite over hypotenuse. Here's the opposite. Divide it by 1. It's that. All right. This was a long lesson. And at least these problems are fairly easy, especially if you can go and look at that, what's that called again? The unit circle. Last thought for you. We are grading the lab tomorrow. This is no more like, well, it's kind of due tomorrow, but I might not grade it then. It's tomorrow. So make sure your lab's ready. And that's all I got for you for today.